Dr. Kisin, we're waiting from you. Sustainability, sustainability, sustainability. I think that's the only word that we're going to hear the next few years. So we are waiting for your presentation. Thank you.
Thank you. Good morning still, everyone. I'm a little bit, still on the other European time. So I will switch the languages, and I hope you will not mind that I do my speaking in English, because if I do it in Greek, it will be very short. So I will try to continue on the topic of sustainability and speak a little bit about carbon capture, what carbon capture actually means, and how we are trying to use that to advance the sustainability for our products. I come from Celanese, and I'm not sure that all of you are familiar with this company. We don't produce coatings, we don't produce paints, we don't produce building materials, we produce raw materials that most of you are hopefully using to formulate paints and coatings. Here, just a snapshot of what we actually do. So Celanese, it is an American company, so we are based in Dallas. The company originates from Germany, so most of you will know about Höchst, the old Höchst. So the Celanese comes from the old Höchst. It's basically the part of that old company. The important thing on this slide, the only important thing is that we have two leading business units within the company. It's engineering materials. These guys are making plastics, which is not super interesting for us. And we come from the acetyl chain. Now, acetyl chain is a little bit of an abstract term, so I try to explain what we actually do and what we produce. So the chain, because we operate across a big chain of raw materials, and what we are doing in our facilities in the US or in Europe as well, we are taking carbon monoxide and methanol as the main input raw materials. Out of that, we produce acetic acid. Acetic acid we can sell into the open market. You know, everybody buys vinegar. A little bit of that acetic acid goes into vinegar. We use the acid to produce vinyl acetate monomer that we also sell into the market as a monomer, but we also use it downstream to produce emulsions, which you can use as a basic for formulating paints and coatings, and we also spray dry those emulsions, and we produce redispersible polymer powders. So that's a uniqueness of our companies, that we actually are backward integrated down to methanol. So it's I would say, the only company that has methanol production, and we can derivatize this methanol down to the powders. And this gives us, I would say, a very nice advantage versus companies that are not using chemistry which is based on methanol. So methanol has one carbon atom, so that's why we like to call it a C1 chain. Other companies are using many times ethylene or propylene-based chemistry. So if we are talking about acrylics, styrene acrylics, they will always have naphtha or oil fossil fuels as the starting material. They will start their production process from ethylene or propylene. So that will be the C2 or C3 chemistry. The advantage of C1, the advantage of methanol and carbon monoxide is that actually nature likes to produce chemicals that are containing one carbon. Even as we now breathe, you know, we inhale oxygen, we exhale CO2. So production process for CO2 is very easy. Nature likes to produce chemicals that contain only one carbon atom. And this is the main advantage that we have, and that we have to utilize if we want to advance, I would think, sustainability and the CO2 footprint reduction of many of our products. Some of the terminology, when we spoke about carbon capture technology, this basically means it's the first, which is of the most interest for us, and I think also for you, is that we would actually like to use the CO2, which is abundantly present in the atmosphere, which is emitted in our processes. We would like to use that as a raw material to produce other chemicals. Some people use sequestration. It basically means you capture the CO2 and you put it into ground as a way to store it permanently. That is not the focus that we are doing. And then there are a few startup companies that are capturing CO2 directly from the air and then liquefying it and using it in certain processes as well. So we really are focusing on using the CO2 as a raw material for the full chain that I showed on the previous slide. And how do we do that? Actually, we have made an investment in our facility in Clear Lake. It's a large chemical park with a lot of chemical companies that are present there. They all emit a lot of CO2. Our chemical reactions produce a lot of CO2. Our reactors are filled with CO2 that is produced in our chemical reactions. So we have invested in a new unit in our Clear Lake facility where we are actually taking the CO2 emissions. We are purifying this CO2. You always have a little bit of other oxides that are present with the CO2, so you need to purify it a little bit. And we are then actually using that CO2 in our reactors to produce methanol out of it. So we use hydrogen and the CO2, and we are producing methanol. Once we have the methanol produced, we can actually derivatize it to make acetic acid, vinyl acetate monomer, to make emulsions, to make redispersible polymer powders. By doing this, actually methanol that comes out of this process is carbon negative. It has a negative CO2 footprint. The moment we go to the emulsions, the CO2 footprint reduction that we get by doing this process is around 30% compared to the standard process that we have. And if we go to the powders, we have another advantage of, again, 20 to 30% of the CO2 footprint reduction. So it is a real CO2 footprint reduction that we are doing. We are actually taking the CO2 and we are derivatizing it into chemicals. And to our knowledge, and our lawyers told me never to say we have the largest scale, but the unit is going to capture, as of January, 180,000 tons of CO2 and transform this into methanol. And then we can, of course, take it through the full value chain. We are capturing this, or we are trying to measure this via the mass balance approach. There is a lot of discussion around the mass balance. Shall it be accepted? Is it greenwashing? Is it not greenwashing? What do we actually mean by mass balance? But we think it's the only reasonable way to make advantage in the CO2 footprint reductions. You know, the mass balance, if you think about it, when you have green electricity that comes to your home, you don't have a separate line that brings this electricity to you. You're still taking something from the network, but you can still account for the number of or the amount of electricity that is going into the network, which is produced by sustainable sources. And we do exactly the same, so our processes will remain the same. When we produce acetic acid, VAM, or emulsions, everything will remain the same, and we will account for the CO2 capture through the mass balance approach. If you think about it, I also, small batch chemical processes are also not very sustainable, very CO2 friendly. So if we would decide to physically separate the flow of our methanol in the full chain that comes from the CO2 capturing technology, it would also not be very efficient. So we need to use the economy of scale, and having the mass balance approach is the only way that we can use the economy of scale to advance the reduction of the CO2 footprint. We offer, as of today, or as of January, there will be quite a number of grades that are available. We call it EcoCC, so Eco Carbon Capture Technology. You can see here everything that is available. So we start from emulsions, from paints and coatings, emulsions for adhesives. They are always based on vinyl acetate monomer, but they can also be vinyl acrylates or vinyl veova or other types of chemistries. But we are producing mainly then the vinyl-based chemistry and offer the products for all of these markets. Next, so I spoke a little bit about carbon capture. That's the main focus of the today's speech and the main focus of the company, where we really think we can make a big impact on the environment. We also have approaches where we are using raw materials that are based on bio raw materials, so something that is coming from food waste, from agricultural waste. We can also offer a lower footprint products. We have, as I said, production facilities in US, in Europe, in China, in Singapore. we can tailor our product mix in such a way that you always get the lowest CO2 footprint, so we can choose from where we want to take each component of our products and lower the footprint by doing that. So actually that's it from me. I hope that we can agree that the CO2 footprint reduction is one of the most pressing questions and issues that we are facing today. And at least I hope I managed to convince you a little bit that the approach that we are taking is going to at least make a first step towards the CO2 footprint reduction for paints and coatings. So, thank you.
Thank you very much, Mr. Kisin.